Yeah, sure. Hi, I'm Richard Campbell. I'm the regional director from Vancouver, Canada. Today I want to talk to you about SQL Server 2005's error handling capabilities and dealing with deadlocks. Now, a deadlock occurs when two connections try and grab the same records at the same time and they conflict with each other. So one connection is updating row 1 and row 2, and the other connection is updating row 2 and row 1. The first connection gets row 1, second connection gets row 2, and they need each other's rows, and they can't resolve it on their own. SQL Server detects this block condition, recognizes the deadlock, and picks a loser. One of the connections gets dropped with an error, the other connection ends successfully. Up until now, SQL Server hasn't been able to handle deadlocks any other than just passing the error back. But with the new error handling capabilities of 2005, we can actually manage deadlocks ourselves inside of our stored procedures. Let me show you how it works. I've created a simple example that uses a contacts table with only 2 rows in it. One's got my name in it, the other one has Steve Forte's name in it. I also have an error log table. It's just going to show us where the error occurred and when it occurred. Here's my stored procedure, and it'll walk us through all the code involved in error handling. So the first thing is, notice I set my deadlock priority low. That means that the stored procedure will always get the deadlock. By the way, you can't set your deadlock priority high, so you can't tell the other guy having a deadlock. Below that are a couple of the new constructs for error handling in SQL Server 2005. There's the begin try and the begin catch. So the try block is the code we want to execute. This code will run every time, and you can see I begin a transaction and I update the 2 rows. Notice I do contact 1 and then contact 2, then commit the transaction. And if there are no errors, that's all the code that's going to run in this stored procedure. Below that is the catch block. Now you have to have a catch block to go with a try block inside of SQL Server. This is a lot like .NET, but it's not as flexible. There's no finally. It doesn't understand all that cool capability. The catch block only runs when there's an error. And you'll notice that my very first line here has the add error in it. So add error is just like it's always been. It contains the last error code that occurred. It's just that instead of having to test after every line in the try block, I'm now able to catch them all inside of this catch block. So I save the value, and then I test it. You'll notice here I'm checking to see if it's a 1205. A 1205 is a deadlock, and that's the one I want to handle. Below the 1205, I have a 2627, which is a primary key violation. Then I sort of have a catch-all for every other kind of error. The reason to code it this way is that I want to be sure that my recovery system, my retrying system, doesn't trap errors other than deadlocks. That's the important part here. And you'll notice that in the code for the 1205, the deadlock error, I roll back the transaction. So that's going to release the locks. And that'll allow the other transaction taking place to complete successfully. Then I write out the fact that I'm attempting to recover from a deadlock, and I use the delay function to wait 10 seconds before I try again. I don't want to keep hammering away here. That little delay will stop the flapping from going on. All right, now if we're going to actually try one of these deadlocks, we're going to need 2 connections. I'm going to scroll up here and get to where I can execute my deadlock test. Now I'm going to switch over to my other connection. And you see here, I'm beginning my transaction, and I'm going to update the last name on contact 2 to direct last name. So I'm going to run that chunk first, then I'm going to skip back and then run the second chunk. So I execute this piece, switch to the other connection, execute my stored procedure. Now, you notice it's blocked. It's not able to write the row because it's trying to write on the same row as this one. Now I update the second connection, the second update, and commit the transaction. There's a little delay here. We're actually deadlocked at this moment. Right? There's a deadlock going on now, but you notice now we've successfully updated and committed the transaction. So somehow the deadlock's been resolved. If we switch back to the first connection, you'll see over here, we're still executing. There we go, we just finished. No errors have been raised at all. The deadlock handlers work just fine. Let's take a look inside the error log table. So in the error log table, you can see we've got 1 row, and that 1 row shows a 1205 error. So that was the deadlock occurring. So both sides have successfully completed. What's happened to the data? You recall from this connection, we updated the names to say direct last name. And on this connection, we updated the names to say SP last name. If we actually look at the data, you see the names are now SP last name. Now, how did that happen? Well, the directs wrote first, right? When the deadlock occurred, the stored procedure released its locks, let the directs write, waited 10 seconds, and then it wrote its own rows out successfully. So we've overwritten the directs. The big thing here is we never raised an error. The deadlock was handled inside of the stored procedure the entire time. Now, out in the production world, deadlocks occur sometimes, and normally we have to propagate those back to the client. The client's always happy to get a deadlock that way. And I think deadlocks are about the only thing that SQL Server wants to handle on its own. If you've got a primary key violation, you pretty much have to propagate that back to the client. There's no way for you to fix it yourself. You find clients get grumpy if you just change their data for them. But a deadlock is a database-specific problem. And so handling it internally actually saves the client some grief. I think it's about the best use of the new error handling capabilities of SQL Server 2005 we've got. Thanks for listening. How's that for time?